going to look at solving radical equations. We have looked at radicals before, but most of the time we have used them in order to solve quadratics. In other words, we've used them to undo. Now we're going to start out with radicals in our equations. So let's first look at the steps to solving radical equations. The first step that we need to do is we need to isolate one radical, in case we have more than one, on one side of the equal sign. And this means nothing multiplied by the radical, nothing added or subtracted to the radical. Get everything away from the radical. After we have isolated the radical, the second step is we're going to raise each side of the equation to a power that is equal to the index. Of the radical. Now, most of the time we have been working with square roots, but this could be a cube root or it could be a fourth root. So in other words, if we have something like this, we would want to square both sides. Now, if we have something that looks like this with a 3 here, we would want to raise both sides to the third power. We could have something that looks like this, and so we would want to raise both sides to the fourth power, and so forth. So you look at what number is here. If there's no number, it's an understood 2. Once we have raised each side to that power, our next step is to solve the resulting equation. If the equation still has a radical, we must repeat steps 1 and 2. So in other words, if we started out with a radical on both sides of our equal sign, we may have to repeat steps 1 and 2. Our last step is to check potential solutions in the original equation, because we need to make sure that our radicals do not become negative. We do not get imaginary numbers, that type of thing. So let's look at a couple of examples of this. So let's look at, if we start out with the square root of a 2x plus 1 is equal to a 5. So our first step is to make sure that the radical is isolated on one side, meaning nothing is added or subtracted, and I'm going to put a little hook here to show that that's the end of my radical, but nothing is added or subtracted or multiplied by my radical. In this particular case, my radical is isolated. It does have the understood 2 here, so I'm going to raise each side to the power that's equal to my index, which is a 2. What happens is this 2 cancels out. It undoes the square here. And so on the left-hand side, I am left with 2x plus 1. On the right side, this 5 squared becomes 25. And I solve as normal, so I would subtract 1 from both sides. I get 2x is equal to 24. Then I divide both sides by 2, and I get x is equal to 12. I need to check, and so I'm going to check that 2 times 12 plus 1 does in fact equal 5. So 2 times 12 is 24 plus 1. 24 plus 1 is 25. And the square root of 25 is 5. So yes, this one does check out. So my solution is 12. Let's look at another example. If I start out with the square root of 6x plus 1 is equal to x. Now notice that I have an additional plus 1 here. I cannot square both sides yet. I have my radical, but I have an additional plus 1 hanging out here, so my radical is not isolated yet. I have to subtract the 1 from both sides. I've got to get this radical by itself first. So I'm going to get the square root of a 6x plus 1 is equal to an x minus 1. Now I have the radical isolated, and I'm going to square both sides. Please be careful. When you square the right side, you must multiply x minus 1 times an x minus 1. Please do not just make this x squared minus 1 type of thing. You actually end up with an x squared minus a 2x plus 1. Because remember, whenever we distribute, we get x squared minus 1x minus 1x plus 1. We combine like terms and get a minus 2x in the center. Because I have an x squared, I am going to move things to one side. So I'll subtract my 6x, and I will subtract my 1. So I will get 0 is equal to an x squared minus 8x. I will factor out common, my greatest common factor, which is an x, and I'll get x times x minus 8, and I will set each of those equal to 0. So I'll get x is equal to 0, and x minus 8 is equal to 0, so x is equal to 8. I need to check both of these solutions. So I'll come over and check. I'll start with x is equal to 0. That would say that 6 times 0 plus 1, and I'm going to take the square root of that, plus a 1 is equal to 0. So 6 times 0 is 0 plus 1. So I need the square root of 1 plus 1. Square root of 1 is 1 plus 1. 1 plus 1 is 2 is equal to 0. 2 does not equal 0. So x equaling 0 does not check out. So this one does not check out. This one's an extraneous solution. Let's check the x is equal to 8. 6 times 8 plus 1 plus a 1, is that going to equal 8? So this is 48 plus 1 plus 1. 48 plus 1 is 49. So square root of 49 is 7. 7 plus 1 is 8. And yes, that does equal 8. So x equal to 8 is my solution. So you have to remember to check your solutions because sometimes they work and sometimes they do not.